Attack web application client. Actually, many of the attacks here is already discussed in other modules. So I'm just going to list different types of attacks in this chapter. That is attack web application client. It includes a cross-site scripting, HTTP header injection, request forgery attack, privacy attack. Privacy attack involves a tracking performed with the help of a remote site by employing a leaked persistent browser state. Redirection attacks, frame injection, session fixation, activist attacks. So let's look at the attack web services. So please note that it is not web server, it is web services. So web applications often uses web services. If web services integrated within the web applications are vulnerable, the applications themselves become vulnerable. Thus, attackers easily target web services. Web applications make these web services available to users through different mechanisms. There is a link given here. You can refer to this tutorial on the web services, which is good for a beginner. Not all web services are APIs, but not all APIs are web services. So, okay. So within web services, we have different kind of attacks. So let's look at the first one, web services probing attack. WSDL files are automated documents consisting of sensitive information about service ports, connections formed between two electronic machines, and so on. Attackers can use WSDL probing attacks to obtain information about the vulnerabilities in public and private web services, as well as to perform a SQL attack. So here the attacker can obtain the information. So WSDL files can be used like a footprinting or a enumeration. So to identify the vulnerabilities in public and private web services. So a web service probing attack involves the following steps. In the first step, trap the visual document from web service traffic and analyze it to determine the purpose of the application, functional breakdown, entry points, and message types. Create a set of valid requests by selecting a set of operations and formulating the requested messages according to the rules of XML schema that can be submitted to the web service. So here is the attacker. We can create a request, valid requests after going through the WSDL documents. So use this request to include malicious content in the SOAP request and analyze errors to gain a deeper understanding of the potential security weaknesses. Again, probing is somewhat similar to footprinting here. So here, using the request, we are including the malicious contents, the SOAP request, and then there will be errors. So the attackers are going to analyze those errors to understand the potential security weaknesses. So to summarize, analyze WSDL documents and find the entry point services, etc. After going through WSDL, construct a request with malicious SOAP message and then analyze the errors to get more information about the weaknesses. So this is about web services probing attack, and there is a diagram given here. You can pause the video and look at the diagram. So next is web services attack, SOAP injection. Okay, before going to the SOAP injection, some important points about SOAP. SOAP follows XML based protocol. It consists of an envelope, and inside envelope we'll have header which is called SOAP header. Uh, please note that soap header is optional. So envelope contains the body known as soap body, which is a required block. Unlike a soap header, body is a must. So we cannot have soap message without a body. So any soap message has to have a body. Soap header contain information related to body, may include some routing information which will guide on where to forward or route the SOAP message within different nodes of a distributed application. Header can also contain authentication credentials or the authorization information, or might contain some transaction information like transaction number. This information will guide the server in how to process the SOAP body. Most of the time, SOAP messages can be generated automatically using a method of a SOAP web service class and a remote server. The first line of SOAP message will have a namespace declared using XML NS attribute as shown in the below example of a SOAP. So the XML NS is highlighted in yellow. So here, as you can see, SOAP contains begins with the envelope tag and the ends with envelope tag, and it has a namespace attribute you called SOAP env, which is declared using XML NS attribute, and the SOAP env is linked to a, URL which contains the SOAP envelope. And then there is a uh, and the SOAP environment encoding style should be taken from another URL which is also indicated here. Then we will have the SOAP body. Again, we are declaring a XMLNS called M, and we have associated to another URL. So the service here is get quotation, and then the quotation name is Microsoft. So and then the body and the envelope are ended here. So in this example, we are declaring, can say declaring, or we are sending a web service named get quotation. Sorry, a named get Microsoft get quotation. Okay, SOAP is a lightweight and simple XML-based protocol designed to exchange structured and type information on the web. So I will repeat. SOAP is a lightweight and simple XML-based protocol designed to exchange structured and type information on the web. The XML envelope element is always the root element of a SOAP message in the XML scheme. SOAP injection includes special characters such as single quotes, double quotes, semicolons, and so on. The attacker injects malicious query strings in the user input field to bypass web service authentication mechanisms and access backend databases. This attack works similarly to SQL injections. So you can pause the video and look at the figure here where a SOAP injection is performed. Next, after a SOAP injection, we'll see SOAP action spoofing. So this subsection is named as web service attacks SOAP action spoofing. So every SOAP request message contains an operation that is executed by the application and is included as the first child element in the SOAP body. When the SOAP messages are transmitted using HTTP, an additional HTTP header known as SOAP action is used. So the operation to be executed is included in the SOAP action header. So every HTML contains an additional header called as a SOAP action header, and this SOAP action header will describe the operation to be executed. The header element informs the receiving web service about the operation present in the SOAP body without the need to perform XML parsing. Attackers can exploit this optimization to manipulate the operations included in the SOAP action headers. For example, consider a web service that includes two operations: create user and delete all users, and is vulnerable to such an attack. So assume that this web service is protected by a gateway, and only authorized users who have direct communication with the web service can perform the delete all users operation. An attacker in front of the gateway can perform a SOAP action spoofing by manipulating the SOAP action header as follows. So here there is a SOAP action header called create user. So this is, as I mean, as the name suggests, this SOAP action is used to create a user in a web application. The attacker can modify this SOAP action to delete all users, and the gateway passes this message because SOAP body consists of create user operation. Okay. So attackers use tools such as WS attacker to perform SOAP action spoofing. So a brief description about WS attacker. WS attacker is a tool for performing automatic penetration tests of web services. It is an open source and easy to use software solution with multiple plugins for different attack types, and it provides a security checking interface. WS attacker provides functionality to load WSDL files and send SOAP messages to the web service endpoints, and can test if any web service is vulnerable to attacks such as XML signature wrapping, SOAP action spoofing, and DOS. So the next attack is web service attack, WS address spoofing. SOAP header can contain routing information called WS address. WS address can also contain an optional fault to address element, which indicates the alternate endpoint to which the response is to be sent in case of any complications or errors. Similar to fault to, there is another element called reply to, to specify to whom the reply is to be sent. This fault to and reply to elements can be tampered. So this is called as WS address spoofing. So in the WS address spoofing attack, an attacker sends a SOAP message containing fake WS address information to the server. The endpoint selected by the attacker receives unnecessary traffic via SOAP messages, and thus the victim will be under DOS or DDoS attack. So this our WS address spoofing is used to perform a DOS or DDoS attack by spoofing the um, WS address, which will contain fault to or reply to. So the attacker can assign this fault to or reply to a victim IP address. So the next attack is web service attack, XML injection. An example of XML injection is shown here. It is shown here. In this, the XML code is injected into the email field of the account login form. So as you can see in this diagram, the account login form has three fields: username, password, and email. So username and password are entered for mark, and in the email field there is a XML script where a new user, this XML script is used to add a completely new user called JSON into the system. So if there is no proper validation or input sanitization, then the server will store the information as shown in the right box here, where the user JSON is stored as valid account. So, so using this, the attacker has created another account for JSON. So next, web services parsing attacks. Parsing attacks exploit vulnerabilities and weaknesses in the processing capabilities of XML parser to create a DOS attack or generate logical errors in web service requesting process. A parsing attack is performed when an attacker succeeds in modifying a file request or string. The attacker changes the values by superimposing one or more operating system commands in the request. Parsing is possible when the attacker executes the .bat or .cmd command files. So in the web services parsing attacks, the attacker will execute the batch command or the command files. Uh, okay, so the web parsing attacks, there are two types: recursive payloads and oversight payloads. In recursive payload, the attacker queries for web services with a grammatically correct SOAP document that contains infinite processing loops, which results in exhaustion of XML parser and CPU resources. So this is like a DOS attack using recursive payload. Similarly, oversized payloads. In this, the attacker sent a payload that is excessively large to consume all the system resources, rendering web services inaccessible to other legitimate user. Again, this is another type of DOS where the payload size is too large, which will consume the system resources and thus restricting other users in getting the services. So, and then the last attack in web services is called you is called web service attacks using tools. So the tools that are listed in Aspen book are SOAP UI Pro and XML Spy. So now, so yeah, this is it. This is the end of this module, web application hacking methodology. So in the next video, we will see the fifth module, which is web API, web hooks, and web shell.